Okay, in this problem we want to solve the equation sine of theta equals sine of 2 theta. Well, since we have this sine of 2 theta, we really need to get it in terms of just plain theta, the way this sign is, so that we can solve this problem. Now if we had sine of 2 theta equals a number, we could use substitution and solve it that way. But since one has a theta and one has a 2 theta, the only way to solve this is to use the identity for sine of 2 theta. Now we know that by trig identities, sine of 2 theta is equal to 2 times sine of theta times cosine of theta. So we're going to substitute that in on the right side here to get sine of theta equals 2 times sine theta times cosine theta. And that's what we're going to solve instead. So now everything has a plain theta. That makes it a little easier. And since we are solving this equation and we have two terms here, both of those terms have a sine theta, let's put them on the same side of the equation so we can factor that out and get it equal to 0 on the other side. So I'm going to subtract sine theta from both sides here. And then factor it out over here on the right side. So if I factor out a sine theta from both terms, I'm left with 2 cosine theta minus 1. So now it's factored on the right and it's equal to, oops, I wrote theta, it's equal to 0 on the left, not theta, it's equal to 0. So we can set each factor equal to 0. So setting sine theta equal to 0 gives us this, and then we need to think about where does sine of theta equal 0 between 0 and pi. It's asking where theta is strictly greater than 0 but less than or equal to pi. Now sine theta is equal to your y over your r, or your opposite over your hypotenuse. So it's going to equal 0 wherever y is 0. The y coordinates are 0 here and here at 0 and pi. Now of course 0 is not included in this interval, so that cannot be one of our answers, but pi is included. So the only solution to that particular equation right there is theta equals pi. And then we have this other equation over here. 2 cosine theta minus 1 equals 0. Okay, then we want to solve that equation. So let's solve it for cosine theta. Move the 1 over and divide by 2 to get cosine theta equals 1/2. And we are looking for answers between 0 and pi. So I'm only looking in the first and second quadrants. So you can either have your unit circle memorized or you can draw triangles. Cosine is equal to x over r. So we want my x coordinate to be rather short at a length of 1 and my radius or hypotenuse to be 2. So that tells me my triangle comes up like this a bit. That's 1 and that's 2. Between the first and second quadrants, cosine is positive only in the first quadrant, so I'm not going to have a second solution in the second quadrant there. So this is it, and from knowing our special triangles, we know that this is a 30, 60, 90 triangle with this reference angle right here being 60, or in radians, that would be pi over 3 as our other solution. And that's it for this problem.